All right, so let's talk about stoichiometry and gases. So, the stoichiometry of gases has one particular quirk, and that's that because of Avogadro's law, that volume is equivalent to moles if you have constant pressure and temperature. So, for instance, if we have an equation that's all gases, nitrogen plus hydrogen gives you ammonia. Obviously, we can say from this that 1 mole of nitrogen plus 3 moles of hydrogen gives me 2 moles of ammonia. Well, I could also say that 1 liter of nitrogen plus 3 liters of hydrogen gives me 2 liters of ammonia. So I can treat liters or volume like moles if I have constant pressure and temperature, and only for gases. Only for gases. So solids and liquids cannot do this. So if I were to ask the question, what volume of hydrogen is necessary to react 40 liters of hydrogen and how much ammonia is produced? Well, if I've got 40 liters of hydrogen and the ratio is 1 nitrogen per 3 hydrogens, okay, well, that's going to give me 13.33 liters of nitrogen. And if I got 40 liters of hydrogen and I want to know how much ammonia I'm making, well, it's 2 ammonias per 3 hydrogens, and that gives me 26.67 liters of ammonia. So you can treat the liters, you can treat liters the same as moles if it's all gases and the pressure and temperature aren't changing. All right, but more frequently, you're going to be using PV equals nRT to convert between volume and moles, and the flow will look something like this. You start with volume, you convert PV equals nRT to moles, stoichiometric ratio to the different moles, and then mass of B. So volume of A, PV equals nRT to moles of A, to moles of B, to mass of B. And you can do this backwards too. You could do mass of A to moles of A, dividing by the molar mass, moles of B, stoichiometric ratio, and then volume of B, again, using PV equals nRT. So let's look at some examples of this. 1.5 liters of hydrogen reacts with excess O2 to form H2O under 2.5 atmospheres of pressure at 300 Kelvin. What mass of water is formed? So I've got a gas. I know the amount of gas, and I want to know the mass of water formed. Okay. So first thing I want to do is find the moles of hydrogen, and that's going to be equal to, right, PV equals nRT. So moles of hydrogen is going to be equal to pressure, volume, over R times temperature, which will give me 0.0152 moles of hydrogen. Multiply that by the molar ratio, which is 2 to 2 or 1 to 1, and then by the molar mass of water, and you find you get 2.74 grams of water. "20 grams of sodium metal reacts with water to form sodium hydroxide and hydrogen gas. What volume of hydrogen gas is produced at STP?" Okay, well, if I start with 20 grams of sodium, using the molar mass of sodium, I can find the moles of sodium. Using the stoichiometric ratio, I can find the moles of hydrogen. So 0.435 moles of hydrogen. Now, I could just say, okay, there's 22.41 liters per 1 mole because it's at STP. But for practice sake, we're going to plug that into our PV equals nRT, right? So PV equals nRT, and V equals nRT over P. So 4.435 moles are 273K, 1 atmosphere, and you get 9.75 liters of H2. Well, let's do some practice. Phosphorus reacts with chlorine gas to form phosphorus pentachloride according to the following reaction. P4 solid plus 10Cl2 gas gives you 4 PCl5 solid. If 20 liters of chlorine gas reacts at STP, how much PCl5 is formed? Now again, this is at STP. So again, we can do is we can say, okay, well, I've got 20 liters, and it's 1 mole per 22.4 liters. Okay. So I've got 0.893 moles of Cl2. And there is 4 PCl5 per 10 Cl2, or you could simplify that to, 2 to 5, 2 to 5 ratio. And then you can multiply that. I ran out of space, but you can multiply that again by the molar mass of PCl5, which is 208.3. Moles of PCl5 will cancel. And you got grams of PCl5, so you do 0.893 times 2 times 208.3 divided by 5. You get 74.4 grams of PCl5. Aluminum sulfide reacts with hydrochloric acid to form hydrogen sulfide gas. Following this equation, aluminum sulfide plus 6 hydrochloric acids gives you 2 aluminum chlorides and 3 hydrogen sulfide. If 45 grams of aluminum sulfide are reacted with excess HCl at 670 millimeters of mercury and 35 degrees Celsius, how many liters of hydrogen sulfide gas are produced? All right. Well, first thing we want to do is we want to start with our 45 grams of Al2S3 and do 1 mole of Al2S3 per the molar mass. Molar mass of aluminum is 23 plus 3 sulfurs. So you get a molar mass of 142. No, it's not. Aluminum is not 23. You know, sometimes it's okay to check the periodic table. Sorry, aluminum is 27. Aluminum is 27. So it's 27 times 2 plus 32.1 times 3, 150.3. Wouldn't have made a huge difference, but you do want to be as accurate as possible. So 150.3 grams. Grams cancels. And then the molar ratio is 3 moles of H2S per 1 mole of Al2S3. So 45 divided by 150.3 times 3, and you get 0.898 moles of H2S. Okay, so let's move this number up here. 0.898 moles H2S, right? PV equals nRT. V equals nRT over P, so multiply that by R times the temperature. It's 35 degrees Celsius, so add 273, 308 Kelvin, divided by 670 millimeters of mercury, divide that by 760, and you get 0.882 atmospheres. So you smack all that together. Moles cancel, liters cancel, or no, liters don't cancel, atmospheres cancel, and Kelvin cancels, and you get liters. Woo! And you're going to get 25.75 liters. So the stoichiometry flow remains very similar, but now, so similar to concentration where you're using the molarity to convert between volume and moles. Now you're using the ideal gas law to convert between volume and moles, but a volume of a gas.